Hello everyone, welcome to the channel you do have. Today we will learn some important topics. So let's see what we will learn today. Today we will learn derived unit, homogeneous equation, Vernier calipers and screwgauge. So our first topic is derived unit. So let's do some simple calculation. We know the formula of speed is displacement by time. Now if I want to calculate the unit of speed using the base unit, that will be for displacement the unit is meter, and for time the unit is second. So it is meter by second, that means it is meter per second. Here meter per second is the derived unit of speed. Basically it has two properties. The first one is derived unit can be expressed through base unit, just like this one, and base unit in derived unit never added or subtracted. Just what we see in this derived unit. The unit was multiplied by each other and the base unit was not added or subtracted. Let's see some other examples. The first one is frequency, and the derived unit will be 1 by second, that means second per 1. For velocity it will be meter per second. For acceleration it will be meter second per 2. For force it will be kg meter second per 2. For pressure it will be kg meter per 1 second per 2. For energy it will be kg meter square second per 2. Here we can see that some of the quantity has a specific unit. So some quantity has a specific unit, though it can be derived from the base unit. Just like frequency it is hertz, for force it is newton, but the unit which we derived from the base unit is different. Now our next topic is homogeneous or balanced equation. If every term of an equation is similar, then it is called homogeneous equation. For example, let's consider the equation V is equal to U plus AT. Here V and U for velocity, A for acceleration and T for time. The unit of V is meter per second and the unit of U is also meter per second, and the unit of AT is meter second per 2 into second, which is meter per second. Now we can see that every term of this equation has the same base unit, so we can tell the equation is homogeneous. Now if an equation is declared homogeneous, then we can calculate the unit of any unknown quantity of the equation. We can see it in the example. Here it is V to the power 2. So for this equation, left hand side is force, that means the base unit of force is kg meter second per 2, and unit for the right hand side is C for unknown, rho for density, which is m by v, that means it is kg per meter cube, A for area, which is meter square, and V for speed, which is meter per second whole square, that means it is C kg per meter cube, then meter square then meter square second per 2, that means it is C kg meter second per 2. So the unit of C is kg meter second per 2 by kg meter second per 2, which is 1. So C has no base unit. So our next topic is convention for the symbol and unit. For symbol, it will be printed in italic form, and for the unit, it will be printed in Roman form, and those two will be differentiated through a forward slash. So here the symbol for time is t, and the unit for time is second, and both of these two is differentiated by a forward slash. Same things is happen for velocity. Here velocity is the symbol and meter per second is the unit, which is written in the Roman form, and v is written in italic form, and both differentiated from each other by a forward slash. Then the data is presented in column or along the axis as a pure number. Here all data is presented as pure number in the table. The same thing is also happening for the graph. So this is the convention. So our next topic is measuring instrument. Basically there are different type of measuring instrument, just like meter scale, which is used to measure to the nearest millimeter, Vernier Caliper, which is used to measure the nearest tenth of a millimeter, and micrometer screw gauge is used to measure the nearest 100 of or 50 of a millimeter. I think all of you know meter scale, so I do not want to waste your time describing it. So let's talk about the Vernier scale. Basically, through Vernier scale, we can measure inner dimension, outer dimension, and depth. Now, in Vernier scale, these two jaws are used for measuring inner dimension, and these two jaws are used for measuring the outer dimension, and this one is used for measuring the depth. After measuring a length or depth or inner dimension of a object, we need to tighten the locking screw. After that, we will calculate the measurement. There are a important definition in the Vernier calipers, which is Vernier constant. So what is Vernier constant? Basically it is the ratio of smallest division on main scale by number of division on Vernier scale. This scale is main scale and this one is Vernier scale. So smallest division of the long scale means the main scale by the number of division in this small scale, which is Vernier scale, is the Vernier constant. Now we will learn how to take the measurement from the Vernier caliper. Basically we need to take two main reading. The first one is main scale reading and the second one is Vernier scale reading. In this image we can see that 2.1 centimeter is the immediate left of the zero on the Vernier scale. So we have to always check which number is immediate left of the zero on the Vernier scale. The number which is immediate left of the zero on the Vernier scale is the main scale reading. Here it is 2.1. So we can write the main scale reading is 2.1. And for Vernier scale reading, we have to check which line of Vernier scale is coincide with the main scale line. Here it is, we can see it is number 3. The number 3 of the Vernier scale is aligned with the line of main scale. So the Vernier scale reading is 3. Here 2.1 is centimeter. Suppose Vernier constant is 1 millimeter by 10. Here 1 millimeter is the smallest division of the main scale and 10 is the total division of Vernier scale. So it is 0.1 millimeter, that means it is 0.01 centimeter. So total reading will be 2.1 plus 3 into 0.01. So that will be 2.1 plus 0.03, that will be 2.13 centimeter. Now let's discuss the zero error of Vernier caliper. At first we need to clamp the jaws together on a Vernier caliper. Then we need to check the zero mark of main scale and Vernier scale. If the zero mark of the main scale and Vernier scale is coincide, then there will be no error. So zero error is 0 in that case. When the zero mark of the Vernier scale is the left side of zero mark of the main scale, then it is the negative error. And when the zero mark of the Vernier scale is the right side of the main scale, then it will be positive error. Now when we calculate the actual reading, we need to subtract the zero error from the total reading. Our next topic is micrometer screw gauge. Basically, screw gauge is used to measure more accurately than Vernier caliper. In screw gauge, there are a anvil and spindle through which a object is placed, and there are a main scale. This one is main scale, and this line of the main scale is datum line or reference line, and this one is the circular scale. This one is thimble and this one is ratchet. Now we have to learn two basic definition for the screw gauge. First one is pitch. Pitch is the distance traveled in one rotation of screw. So if the circular scale rotate on time, then how far it will reach in the main scale is called pitch. The second definition is least count. It is equal to the ratio of pitch of the screw to the number of the division on circular scale. So P is divided by the number of division in the circular scale is the least count. The total reading is main scale reading plus least count into circular scale reading. Now we will learn how to take the reading from a screw gauge. We need to take two basic reading, the main scale reading and circular scale reading. To get the main scale reading, we have to check the circular scale. The left side of the circular scale, there are some vertical line. In the vertical line, some are above the datum line and some are below the datum line. So we need to notice the both. Here, the left side of the circular scale, we see two line the upside of the datum line. These two represent 1 centimeter, 2 centimeter, and this one is for 0.5. So the main scale reading is 2.5 centimeter. Now we need to determine the circular scale reading. For circular scale reading, we need to see which line of the circular scale coincide with the datum line. Here, this line of the circular scale coincide with the datum line. So, the circular scale reading is 35, 36, 37 and 38. Let's assume that the pitch is 1 millimeter and the total division of the circular scale is 100. That means it is 0.01 millimeter. 2.5 centimeter means 25 millimeter. So the total reading is 25 plus 0.01 into 38, that is 25.38. So it is the length or dia of the object. So our next topic is zero correction in screw gauge. To determine the zero correction, first clamp the anvil and spindle on a screw gauge, then check the zero mark of the datum line of the main scale. If the zero mark of the datum line or reference line coincide with the zero line of the circular scale, then there will be no zero error. If the zero line of the circular scale is below to the zero mark of the datum line or reference line, then it is positive error. And if the zero mark of the circular scale is upside of the reference line or datum line, then it is negative error. The actual reading formula is as same as Vernier scale formula, which is total reading minus zero error. Now for your practice, I gave you some exercise. If you understand all of the topic which I teach you today, then I think you will solve the problem your own self. But if you cannot, don't worry. I am here for you. I will solve those problems in the next class. Till then, stay connected and thank you for watching.